Hello, this is how to create an engineering drawing or model from a 2D based drawing which is quite cluttered and not to the correct BS8888 standard. So just going to show you our model. So this is our model, which is a component off of a vice system. Particular component bolts using 3 fasteners on a 30-degree angle onto a secondary system, and then has a threaded hole through the top for a handle and screw. So this particular component hasn't been laid out within the best way. So essentially this component here is the front view. Okay, this component here is the top view, and this component here is the side view looking at this way. So essentially what we should have is a front section here, a side section there, and a top section looking down. So this particular view should be in line like so. So we should have our top, our front, and then our side. So what we're going to do is we're going to change this drawing, which is not correctly laid out, into our next component. So to make my life easier, what I'm going to do is I'm going to draw all of the necessary information where I need it. So first stage is I'm going to focus on the top and the front. So quite simply, all I'm going to do is draw a square to simulate my top, just really basic drawing. Here. So there's the top. I'm just going to draw my front view now. Like so, and now I'm just going to draw my side view. Very straightforward. In a second, I'm just going to jot down all the key bits of information so I can start the next process. So what we know is that here to here is 35, so we know we've got that dimension. We know that here to here is 20.65, so with that dimension there. We know that there to there is 24, and there to down there is 24. The centre of my hole is 12.65. Okay, we know that that component there is 35 as well. So this component here is 10, which actually relates to this component here, so this part is also 10, and that makes that part 10, and the middle bit is 15. We know that this part here is 25.5, and the overall height is 50. We have to be careful of in this drawing is when you zoom in, it's like this 24 here, and that line there is actually 0.5 mil gap between the two. So 25 is and then 24 obviously only make 49.9. So okay, so we've got those dimensions there. Just going to go back, just going to look at this additional side view here. So we know that the whole here is an M12 1.75. So essentially that's C. There it is going to be M12 by 1.75, and the whole inner is going to be 10.2. Because that's the size for an M12 for the drill size. We know that from the left hand edge to the centre, 17.5. The top down is going to be 12.5. So we have those two and the thread. Okay, last one is we know that that is all on a 30-degree line there, which we're happy with. This point to this point is 25. Okay, and then we obviously have M8 times 1.25. And then we have CSK11 to Celtic 11, and then a 6 diameter in the centre, so we're happy with that. Okay, so that's our drawing complete. So obviously I've split it all onto TVs, but hopefully that should aid my my drawing skills a lot easier now. So okay, so I've just loaded up Solidworks, and obviously because we're doing a part drawing, this is the welcome screen that will appear. Sometimes it may look like this format. Sometimes it may look like this format. Depends on how your system is obviously set up. Sometimes as well on advanced it may appear to look like this. So again, it depends on how old your SolidWorks system you're using. But essentially, if you load up a part, that's the first stage where we should be heading towards. So again, all I'm going to do is just talk you through the stage. So remember, in this area here is our front view, this is our top view, this is our side view. The others are going to be referenced into our 3 to draw apart. And obviously we have my rough sketch just to help me figure out what dimensions going where. So here we go. So I'm going to draw on my front plane. I'm going to use the corner rectangle here. So SolidWorks is very much a click-based system. So we're going to do it 50 high by 35 wide. Now sometimes I have this set and turned on where it brings up the dimensions automatically in SolidWorks just by going into preferences, opening up the general tab, going down onto display, and I can tick my it's just a couple of options that I've got set. So I've got my dashed lines for hidden, parts are going to be assembled the whole time as well. Also on drawings, just make sure again I've set mine up so it's a bit more customizable. So I've got symbols with revision, etc. Because obviously I do engineering, so break lines as well with break views as well. So I've got our display style here, so I've got high quality edges. I'm going to use draft quality just to save the performance on my PC. With obviously like the highlight features just sit within general as well. So you can customize SolidWorks to however you want as well. So which is all fine there. So if you don't have this set and turned on in general, then you normally have to click and then place your smart dimension. Now I've got two basically the same, so if I delete both of these, it will allow me to put a smart dimension on, and I can basically bring something up a modification box. I can tweak the numbers to I see fit. So when you're in sketch mode, this is the sketch toolbar. Got all our different features in here: trims, circles, ellipses, offsets, mirror tools, functions, moves, repeats, rotates. And then as soon as you're happy with the 2D side, you can then use the features tab and then go into extrude or revolve depending on what you want to do. So again, this is obviously another 35mm product. So 35 I'm going to tick to accept. So this is me basically, this is obviously my top edge, my front edge, my right hand side as well. So just going to use the hotkey, so use Control 1 just to orientate it to the front view. Right click on the surface, start a new sketch. Now I'm just going to draw from the corner. I'm going to show you how to do it if you haven't got that set and turned on. Like I talked about earlier, this would be 25.5, which would be the edge, and then 20.65. So I'm just going to confirm those. 20.65, which is there, 20.55, which is there. So I'm happy with those. So done with my 2D. Into features, this time I'm going to do extruded cut. I'm going to do through all. Just rotate around to show you, so I'll go that way through the product. If it's obviously the other way, so it's flip side, it will come through that way, and it won't obviously work. So you can change the direction. Or if you had a split view, you can go through both as well, so just entirely up to your choice, but I'm just going to go through all. And Control 1 again, just going to assemble my front view. I'm happy with that particular component. There's a couple of different ways you can do this. Next thing, I'm going to put the hole in my center. So this is going to be a tapped hole, straight through with no countersink. I'm going to straight tap. Metric bottom tapped hole, it's an M12 125, it's through all. I'm going to show the threads through all. I'm trying to show cosmetic thread as well, just as an option. Click on the face, it's going to go on. Or if you snap onto my origin point, that will always be in the halfway line, so I don't want to do that. I want to just off center slightly, so I can smart dimension it to my settings. So obviously 35, 17.5. And with 12.5 down, so again, just go back to drawing, double check him, 17.5, 12.5, so we're happy with that. Once I'm happy with my hole, tick to confirm, and then puts the C in to say obviously that it's threaded. So next up, I'm going to put my chamfers in, so I'm going to go into the fillet, drop down for chamfers, select my two edges, we know that are 10mm. Tick that off, and I'm going to choose the front edge for my last chamfer, which we know is going to be 24. Like so. So that's that one there. Now sometimes some systems will show you cosmetic threads or not. So you want to see that it's a cosmetic thread, if you go back into your system, documents, dimensions, then we go into detailing, you can go show cosmetic threads as on as well. Also, I'm just going to check so that datums are all correct, angles are all fine, yeah, so it's very customizable. You can change units as well. So Solidworks is always very good, and it's just got me a cosmetic thread just to say that it's threaded for a visual view. Last one then, can we come around to the left hand side, so can you Control 3. So before you could draw on I can make a sketch. I could say, well, I want a midpoint line like so, or I could basically just draw a center point depending on whereabouts I want my system, but essentially I'm just going to draw 25mm line from a smart dimension, the midpoint to the base. I think that's going to be 12.65, yeah. 12.65 in the middle to the side. Smart dimension side to the center. Again, I think it has to be 17.5, yeah. So 35 divided by 2, 17.5. Slap, bang. And again, you could actually just do a 25mm circle as well, just to get your points set appropriately for your next phase of aligning the additional circles. So I'm going to rotate that line. Center rotation is going to be in the middle, 30 degrees. So you don't actually need a circle really. So you know, again, the circle's just over there for use, or you can use it just as a point as well. Come to Hole Wizard now. I'm going to do my CSK11, so countersink 11. So this is obviously for this type of screw. So obviously technically it's named 6, but obviously the sizings are slightly wrong. So because it's not actually threaded, so it's just sort of specking up the size holes. And change that to 6. Change that to 11. Go to my position, click on the surface, click, accept, and then I'm going to go back into the hole again. This time straight tap. Reset the other ones, I want it the same. It is M8. It's times 1.25. Yeah, 1.25. Position again on the center. Tick to accept. That's that point. Now we can go in sketch 5 hide, so it doesn't appear on the surface. So there is our drawing, which is quite nice. So I'm going to save that as my vice block. So I'm just going to call it VB. I've got a VBU, so I'm just going to do VB 101, just to keep it away. So I normally save all my parts as a part number rather than a header, because SolidWorks, when you go into a make a drawing from a part, it copies the file name across. So I'm going to choose A3. So you can choose a view and bring it on. We can go view layout and then just use standard 3D drawing. Double click VB1, and there is my part nicely laid out. I'm just going to up the scale. So you're going to use custom scale and change the scale, to 2 to 1. But it doesn't update the sheet, so you need to use the sheet scale really for engineering. Right click, properties on the sheet, and change the scale 2 to 1. Apply the changes. Get everything's referenced off of the first drawing, so just sort of make sure you give yourself really enough room. 2 to 1 is probably slightly too big really, but Finally, again, you can change the qualities. You can put in like your hiddens, if you want your hiddens, or up and down the. So I'm just going to put my hidden detail in actually. Like so, I'm happy with that. So I'm just going to come in and do some annotation work. So I'm going to say that line to that line. There is 10, like so. That's 35. 35. So again, because you're in Solidworks, there's really nice snap functions that you can use. 50. I'm going to say there to there. 24. There to there is 24. And again, you can drag your lines back just to make it really a bit more smarter. Like so you know it's not getting in the way of any views. I can go here to here, point to point, 25.5 point to point as well. Again, just keeping it nice. Slight overlap. Let's put a nice little crosshead in that corner. So then we have a hull call out, which we can say that this, this hull is a 10.8 for all. Slightly big on drill size, normally 10.2 for an M12. That's fine. Also, you can do a nice hull call out here as well. So again, the snap function is really good in Solidworks. Really nice and clear. What also we could do is we could do a smart dimension between centers. More on the angle really. So I'm just going to put a sketch line in off of the snap points. And so just annotating the drawing just to give it some few more components. So just looking at a couple of extra bits. 11, 50. So then just doing the checks, 35 all. 10. Good if I wanted to. Populate that side. As well, got holes, so I just need to put there to the center. Do it off the other edge. Okay, so let's just move that around there, make some space. Let's go to that 35 a second. Okay, so 12 and a half. 14 at 15. Kind of needs to be there really. Unless you put a centre line in, but yeah, and I think that's fine. So I'm happy with that. Whole centres. Let's put the last sentence in this side. Right, so okay, it's happy with that. We could actually, if you wanted to, put a projective view of that in, so you could have a nice sort of 3D model of it. I'm just going to move it slightly off the projective view and just shrink the scale down to 1:1 just to make it fit a bit nicer. Like so happy with that. Get tick that off, and then I can now come in to edit the sheet format. Come down, so I can just put check line, any approval, factory manager, or quality assurance. Finish, you can just put it as same machine. You can put a surface tolerance if like you wanted in here, and just so you can just put a surface tolerance of, I don't know, 1.6, which is normally a machine finish. C plus straight minus. Um, 1.125. I don't need linear angular, I'm just going to have a standard tolerance. Debug, dot scale, revision 1, title, so titles is one of the ones that sometimes block caps does look a bit angry, so just be careful. EN and 3 still. That's why we always name our files by our drawing numbers in Solidworks, because it copies across. So A3, happy with that. So I can buy out this sheet and then just go back to edit sheet, and that will allow us to have our sheet. And again, we can then just save as. You can either save it as a PDF. It'll PDF out in a nice drawing format for you. So just go to my folder. So there we go, a nice technical drawing done by SolidWorks. Very, very easy. We've got our different views that we can obviously zoom in on. Just part of Adobe as well, which makes it quite nice as well. So that's how you create a very cluttered drawing into a part, into a SolidWorks model, and SolidWorks model back into a technical drawing fit for the workspace. Okay, thanks for watching.